Welcome to study guide number 2. We are going to do numbers 1 through 8. You'll notice that there are 9 problems, but we're going to cross out the last one. So we'll do numbers 1 through 8, and you'll find them on pages 53 to 55 of the green book. All right, so let's start with number 1. It says sketch the graph of the function, and we want to identify the x-intercepts. So we're going to sketch. We're going to identify the x-intercepts, and then where the graph is positive and negative. So let's get started. Well, first we're going to find our x-intercepts. Since we're already in factored form, we can set the function equal to 0, and we'll find x-intercepts at x equals positive 2, and at x equals negative 4. So I set this equal to 0, and I set this equal to 0. Next, we're going to plot what we got. Go to positive 2. Go to negative 4. Okay. And now we're going to discuss where our graph is above and below the axis. So to the rightmost, in the rightmost region, my graph is going to be positive because there is no sign out in front. And whatever the sign out in front is, well, since there's nothing, that means it's a positive. Well, that's how our graph behaves at the rightmost end. Now, at 2, we're either going to flip or keep our sign. So an odd power means flip the sign. And even power means keep the sign. So at x equals 2, I got that from this factor right here. Our power is invisible, meaning it's a 1, which is an odd number. Since it's odd, I'm going to flip the sign. So what's the sign that I'm flipping? Well, it's this one. Okay, as I move to the left, well, now this region is going to be negative. It's going to be below the axis. Okay, let's keep moving left. Now I have a decision to make at x equals negative 4. So go to where you got x equals negative 4. The factor has a multiplicity or an exponent of 2. Well, even exponents means that we're going to keep the sign. Basically, we're going to bounce. So if my graph is negative in this section, then it's going to remain negative. I'm keeping that sign. Now we simply have to connect the dots. So let's start again in the rightmost region. So I'm going to start above the axis because it says positive. So start above the axis, and then you need to go to the nearest x-intercept. Now at 2, between 2 and negative 4, in the middle region, I'm below the axis because that negative says, hey, you need to be dipping below. Then you need to hit the nearest x-intercept. And at negative 4, to the left of negative 4, we need to stay negative. So we're simply going to bounce off. So make that nice and smooth. And now you have your polynomial graph. Okay, so we got our sketch, we got our x-intercepts. Now we just have to say where we're positive and negative. So according to the signs we have here, I'm negative from negative infinity to negative 4. And then again, between negative 4 and 2. And I'm positive from 2 to positive infinity, basically to the right of 2. All right, let's do part B. So again, we first find our x-intercepts. X-intercepts by setting the function equal to 0. So I got x equals negative 2, x equals positive 3, negative 1, and then we'll immediately plot them. So that's 3. It's negative 1, and then we have at negative 2. Now, one of the useful things that you can do right away to save yourself some time is just go ahead and write in all the invisible exponents immediately. So this is x plus 2 to the power of 1. Wherever there's no exponent, we have a power of 1. And remember, odd exponents mean flip the sign, and even exponents, we're going to keep the sign. So once we've identified our x-intercepts, now we decide, starting on the rightmost section, whether our graph is positive or negative. As we said before, that depends on the sign out in front. Here we have a negative, so that means that my graph starts below the axis, negative. Now we have a decision to make at x equals 3. So go to where you got x equals 3. Look directly above that. We have an odd exponent. Hey, notice all of our exponents are odd. That means that each x-intercept, we're going to flip. We're going to keep flipping our signs. So I'm going to go ahead and save some time. I'm just going to go ahead and flip at each x-intercept. That was fast, right? So now we just have to connect the dots and draw our graph. So this time we're not starting above the axis like before, because this says, hey, you're negative on the right side. So we're going to start below the axis, hit at the x-intercept, and we're going to cross and go above, because right here it says, hey, you need to be above the axis. Then we're going to hit, dip below, hit, and cross again. So we're positive from negative infinity until negative 2. That's the leftmost. We're also positive between negative 1 and 3. We're negative between negative 2, negative 1, and then also starting at 3 until positive infinity. That's our graph. Okay, let's move on to number 2. Number 2 says, determine if x minus 3 is a factor. So remember, if something is a factor, that means it multiplies evenly into this polynomial. Well, if it multiplies evenly into it, that means that it has a remainder of 0 when we divide. So essentially, we're going to check if x minus 3 is a factor by doing division. If we get a remainder of 0, that means it is a factor. So let's do division. We can do long division or synthetic division in this case. I'm going to do synthetic division, and the number that goes in the box would be x equals 3. Now I need my coefficients. 2, negative 15, 22, 15. Always bring down the first number, multiply. 2 times 3 is 6, then add down. Negative 15 plus 6 is negative 9. Multiply negative 9 times 3 is negative 27. 22 minus 27 is negative 5. Negative 5 times 3 is negative 15. And then 15 minus 15 is 0. Remember, that's our remainder. We got a remainder of 0, meaning yes, x minus 3 is a factor. But actually, the instructions don't just want us to see if it's a factor. It says, looking in your book, it says, if it is a factor, then complete the factoring. So factor it all the way. Well, when we divided by x minus 3, this was the answer we got. 2x squared. Remember, we're going to drop the power. So we started with the cubed. It means our answer needs to be squared. Minus 9x minus 5. Right? So that was our answer to the division problem. Well, hold on a second. If this divided by this gave me that, right? That was the answer to my division problem. Well, that means that this times this will take me back to the really big polynomial. And so I need to rewrite my polynomial, p of x, as these two pieces multiplied together. So x minus 3 times 2x squared minus 9x minus 5. Okay, we're not factored all the way yet, because notice we can actually continue factoring this quadratic here on the right. Since it's a quadratic, we don't need to do anything fancy. We'll just use our old magic x. So we need two numbers that multiply to negative 10 and add to negative 9. Those numbers are negative 10 and positive 1. However, since we have a number out in front, we need to take special precaution and divide both of those numbers by 2. On the left side, that reduces to negative 5, but on the right side, this does not reduce. So remember, if it reduced into a whole number, then that's fine. That's just going to turn into x minus 5. But if it doesn't reduce, we're not going to write x plus 1/2. No, 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 no. We put an x in the denominator, and we read this upwards. That's 2x, and that's a positive 1/2, so 2x plus 1. And that's how we factored this portion. But don't forget, the entire polynomial also has the x minus 3. And there we go. Now we're fully factored. So again, we used synthetic division to get our first factor, and then we used magic x to continue factoring it all the way, and that was our answer. Let's do one more. Okay, determine if x minus 3 is a factor. So again, we're going to use synthetic division so if we want to see if x minus 3 is a factor, set equal to 0, and that's the number that goes in the box. And now we need our coefficients. Now this question is tricky because it's actually missing one of the terms. So we need to put a placeholder. Well, the missing term is x squared, and if it's not there at all, that means that we're going to have 0 x squared. So we need to put a 0 in the placeholder. So my coefficients will be 1, followed by 0, followed by negative 13, and then 12. 1 times 3 is 3, 0 plus 3 is 3. 3 times 3 is 9, negative 13 plus 9 is negative 4, and then negative 4 times 3 is negative 12, and we get a remainder of 0 again. That means x minus 3 is indeed a factor. So we can rewrite this as the product of x minus 3 and x squared plus 3x minus 4. I just rewrote this as my final answer. So p of x therefore equals x minus 3, the thing we divided by, times the answer that we got. Similarly to before, we need to continue factoring this all the way, so we'll do magic x on the right side. The two numbers that work in this case are going to be 4 and negative 1. Since there's no number out in front, it's just a 1, we can use our previous shortcuts, which is just to rewrite this as x plus 4 times x minus 1. And now we're fully factored. Okay, let's do one more. Let's finish this problem. All right, it says given that g of x, it wants me to actually find g of x, which is over here, right? Plus f of x, which is right over here. So I'm just going to plug them in, keeping in mind that I'm adding the 2. So g of x, that's 5x minus 2, plus f of x, which is 15x cubed minus x squared, plus 13x. This is a simple combine the like terms problem. So let's start with our highest degree, which is 15x cubed, followed by negative x squared. They had no like terms. But now we have positive 13x and positive 5x. So 13 plus 5 is 18x. And now I'm just left with minus 2 at the end. Easy. So C is a little trickier because this one has a minus sign in the middle. So I'm going to subtract f of x. And when I subtract an entire function like this, I want to make sure I'm subtracting the whole thing. So we're going to need to put parentheses after that minus sign. So let's write this one out. All right, g of x is 5x minus 2, and I'm going to subtract from it. All of f of x is going to go in here. 15x cubed minus x squared plus 13x. So now what? Well, we have to distribute that negative 1. That means that all these signs are going to flip. So I have 5x minus 2. Let me rewrite that. 5x minus 2 minus 15x cubed plus x squared minus 13x. And that's what makes this problem harder. Now we continue as before, just combining our like terms. So let's start from here. Negative 15x cubed Followed by plus x squared, followed by negative 13x plus 5x, which is minus 8x, and then the minus 2 at the end. Now that's all I have time for in this first video. I'll make a second half with the rest of the study guide.